Hello and welcome. We are going to plan a flight today using a tool called ForeFlight. We're going to use the web-based version of this, and there's also, for your awareness, there is also an app version, an iPad, an iOS version of it, and just to kind of set the stage, the goal of this is it's an introductory course or an introductory video. Giving you a pretty good idea of the elements of creating a navigation log in ForeFlight. And then the details, the big idea is to take your theoretical knowledge and bring it over to the practical world and then define, variation, deviation, and wind correction angle so that you can see it inside of the navigation log. Okay, so here's what we're going to do. We're going to start over here at flights. I've already planned out a flight from Torrance to Camarillo. We're picking 4,500 feet. Estimated time of arrival is set up here. Estimated time en route, 27 minutes. And our course is going to take us through Santa Monica. Okay, so what I'm going to do, I'm going to show you how we set that up under ForeFlight using the Flights tab. There's a couple of ways of doing this, but today we're going to use the Flights tab. So I basically created Add New, which created this, and from here we got this presentation. And I started with estimated time of departure, ETD. We could look at the ETA, estimated time of arrival. So ForeFlight gives you that option. We have 7:30 Zulu. We're departing Torrance and we're going to Camarillo. Okay, now there's some other details here. Takeoff information gives us the wind direction, wind speed, temperature, altimeter setting, which are all significant when we're doing performance calculations and so on. We're not going there today. And then there's some basic information about what is Torrance Airport, the departure airport. And that becomes kind of at our fingertips information. And then the same stuff's available for Camarillo. So again, our landing information, 160 at 3, temperature 18, altimeter setting is this. And these details help us do calculations in terms of doing our landing information. We don't have an alternate. We're going to use this airplane 330 Mike Echo. It's a 172. Our performance profile, we're going to fly pretty much max power, 2650 RPMs, and we're going to go through Santa Monica. We're going to use an altitude of 4,500, and we're going to be doing VFR, Visual Flight Rules. Payload, today we're taking 2 people, both about 200 pounds, 150 pounds of cargo. Total payload is 550 pounds. Our fuel policy, which again, I'm not going to go into all of the details on this, but this is maximum fuel. That is, the idea is that we're going to take off with max fuel and then always have extra fuel in the tanks. And there's a couple of other ways that we can do that. Again, I'm not going into this. We're going to use max fuel. Here's your fuel allocation, 318 pounds, which gives us 53 gallons of fuel, or 53 gallons of fuel is 318 pounds of weight. Fuel flight looks like we're going to burn about 36 pounds of fuel, or 6 gallons of fuel. Taxi looks like that's about 1 gallon at 6 pounds, so we're going to burn up 1 gallon of fuel on taxi, and our fuel to destination today is about 30 gallons or 5 gallons to get to Camarillo. Fuel at landing, this assumes we're starting with 318 pounds. All right, you can kind of see where the numbers are come from. 282, that's how we get to this. Alternate fuel, reserve fuel, we still have over 35 pounds of fuel. And this is a manual entry, so we can change that policy. Again, we're not getting into this. I'm just giving you the overview of this. We have extra fuel, and that amounts to 41 gallons. You add all of that up, and that gives you 53. Okay, so we'll kind of close those down. Our zero fuel weight, 2213, that is the basic fuel weight, the basic empty weight of the airplane. Ramp weight is 2513. Actually, I need to go back to this. So zero fuel weight is going to be the weight of the aircraft without any fuel, and that's 2213. not the empty weight of the aircraft. Ramp weight this is the total mass of the airplane with everything on it, fuel, and the 550 pounds of payload that we're bringing with us. And after taxi, we're going to be at 25 pounds for takeoff. We got our fuel. Okay, destination services. Again, this goes beyond what we're going to do today, but you see how I've got everything set up, right? So that's the general overview. Again, what do you need to know about this as a first time going through this? Really not much. I wanted to give you the overview so that you had some idea where everything is at. The things that we have to be aware of: where are we departing, where are we going, and then what is our routing? How are we going to get there? Okay, I'm going to push this over so that we can see it on the map. Okay, and so there's a button here I'm going to click on. That's going to send this over to the map. You're going to see some lines being drawn, and that's the flight for today. Okay, zooming in on this, so there's Torrance. We're going to take off out of Torrance, go to Santa Monica, and then eventually get to Camarillo. That got copied over here. If I wanted to change something, let's say I put in the Fillmore VOR, for example. Right now, I'll zoom out so that we can see that. Actually, that's not the Fillmore VOR. Sorry about that. Get rid of that. Fillmore is right. Well, where'd it go? Well, let's use, without fighting this too much, Gorman will actually serve the same purpose for what I want to show you, right? So adding another waypoint will take us out away from that. Here's the Fillmore VOR there, right? So we're not going to go all the way out there, so we're going to delete that, and that brings us back there. So that gives you some idea how we can edit this. Again, the point of this whole thing is to get you familiar with this as a tool and take your theoretical knowledge and move it over to your understanding of how we apply it in the real world and how this works. Okay, so there's our course. A couple more things about this. The reason we're going Torrance to Santa Monica, there's something called special flight rules that will take us directly over LAX. We have to be at 4,500 feet, so that's part of the reason I picked 4,500 feet. The other reason is this terrain over here. If we're at 4,500 feet, we will stay well above the terrain here. The other reason, we've got a shelf of Bravo starting at 5,000 to 10,000, so we've got to stay below that because special flight rules is only this little bit of space here. Okay, so once we leave this, we're no longer in the Bravo when we come out here. Oops. But we could go into the Bravo if we climbed up to 5,000 feet, right? And if this doesn't look familiar, you're not familiar with this, please go back, look at your airspace stuff. So you should know the floors and ceilings of airspace. Okay, so then we get to Santa Monica. We're going to make a left-hand turn. And then as we've got it set up, we're going right to Camarillo. Okay, so that's the flight. It's actually quite easy to build these, and as you saw when I changed it, you know, it's super easy to fix and update and so on. The details matter, so pay close attention to how you're building it, where you're going, those kinds of things, because it's super easy just to plot a course and not pay attention to airspace or terrain. Those are super important elements to be conscious of and aware of. Okay, so let's take a look at the nav log. We'll come back over to flights, and then I'm going to click on nav log, and that's going to give me, it's going to build what my nav log looks like. Okay, and as I look at this, okay, it gives me Torrance Camarillo on this date with this airplane. It gives me my performance settings, so 2650 on the RPMs, some details about the flight. Okay, I'm going through Santa Monica as I presented to you already. This has to do with GPS, and we won't get into this today. Again, this is an extra. So there's a lot to this stuff, right? There's still a lot that goes on with this. The goal of today is really to get down here and look at the nav log. Again, here's our fuel review. Okay, and this sheet right here, typically gets printed and brought with you on your cross country. Okay, here's our empty weights. Right, there's our basic empty weight. There's our payload, and to get our fuel, right, the difference is 1663 plus 1550, and then whatever that difference is to get us to 2525 is our fuel load, which is about 318 pounds. Okay, so all right, 2 people on board, nothing new, nothing's changed. A couple of details here. These become important pilot notes when we take off, when we land, when we get off the ground, when we get on the ground. There's a couple of things there to pay attention to. Departure ATIS, again, we'll go over some of these. If we needed a clearance, we'll have that. And our focus is going to be on this right here. This is what we want to emphasize and make sure that everyone is understanding. So we're departing Torrance, going through Santa Monica, and going to end up at Camarillo. This right here is something we call top of climb, TOC, and this is what we call top of descent. Top of climb is as we depart Torrance, we're starting at about 100 feet, and we're climbing, and we're going to climb up to, right, our planned altitude of 4,500. It's going to take, let's see, in terms of distance, it's going to take approximately 10 nautical miles to get to 4,500 feet. Okay. And that'll leave us with 38 miles remaining for the flight. All right. And then top of descent, okay, we're starting at 4,500 feet, and we need to plan our descent. We need to start descending so that we don't end up at 4,500 feet over the airport. So we want to have a thoughtful way to plan that. And this top of descent is where we begin that descent. And again, that's 21 nautical miles from our start, or 13 nautical miles from Camarillo, right? That's the last leg. That's the remaining distance on that. All right, so what I want to do is go through one of these and break each of these down. So let's take a look at Santa Monica leg, okay? And we're going to go to our top of descent, which is looks like about 4 nautical miles before we start that descent. So Santa Monica, okay, and if we can get into this, this gives us a latitude and longitude, okay? It doesn't give us a typical degrees, minutes, and seconds. It gives us a decimal version of latitude and longitude, which is another way of providing lat and long. This gives us the frequency. SMO happens to be the Santa Monica VOR, and that's on 110.8. Okay. And by the way, anything that starts with the letter K is going to be defined in the United States as an airport. And then when you see these 3-letter identifiers, those are typically going to be a VOR. If you see a 5-letter identifier, that's generally a GPS fix or an intersection. Okay, a little extra on that. All right, so that is this box right here. And if we come over here, and we're basically DCT is direct, we'll be at 4,500 feet. And then MSA, which is the safe altitude, the minimum sector altitude. The next line addresses winds. Okay, and so when we are looking at this leg, Santa Monica to top of descent, you'll notice this first element is, in this case, it's a T and then the number or the letter, the number 6. Okay, and this simply means that you have a tailwind at 6 knots. If it said H, we'd have a headwind at whatever number preceded or followed it. And then below this, we have the wind direction. They're calling winds at 134 at 07 or 007 knots. Okay, and then this next element is outside temperature. Okay, and then this is the differential in terms of standard temperature for this altitude. Couple of details on this. Remember, standard temperature at the surface is 15 degrees Celsius. All right, and at this altitude, 4,500, Generally, we lose 2 degrees per 1,000 feet. So if we're at 15 degrees, we go up 1,000 feet. We should be at 13 degrees, go up to 2,000 feet. We should be at 11 degrees, go up to 3,000 feet. We should be at 9 degrees, go up to 4,000 feet. We should be at 7 degrees, go up 500 feet to 4,500. We should be on a standard day at 6 degrees Celsius. Okay, and what this tells us, it's actually warmer at altitude on this, warmer than standard on this particular day. Why is this important? This comes into play when we start doing our performance planning in our performance numbers. Okay, the hotter it is, that has an effect on the performance of the airplane versus it being cooler on that particular day. So those numbers kind of play in are important kind of indirectly. Okay, and it's important to know what the performance of the airplane is, and so that's why they give that to us, particularly when we get into density altitude. All right, so that's our wind column. Okay, so let's take a look at the next column, which has to do with magnetic heading and magnetic course. And generically, if you're applying the theory to what's going on here, so in the ASA book as well as the PHAC, it describes the conversions between true course and then getting it into something that's usable for us in the airplane, which would be ultimately compass heading. Right, and the idea would be is that if everything failed, we'd still have the compass heading to fly off of. Okay, so magnetic heading, for example, we're going to be dealing with wind correction angle, okay, which we have the winds addressed here, and then we're also adjusting for something called variation, and then that's going to give us this number here. Okay, when we talk about magnetic course, it's almost the same thing, but there's a significant difference. We are not considering the wind correction angle in that calculation, if you will. Okay, so in this leg from Santa Monica to our top of descent, our magnetic heading is 324. ForeFlight has taken into consideration the winds, okay, and it's adjusted the wind correction angle for us. And it's only off of by a degree or so. And then secondly, it's also taken into consideration the variation, okay, which when we talk about variation, there's a difference or a differential between true north and magnetic north, and those differences are actually different across the globe. So depending on your location on the globe, your variation is going to change. We'll take a quick second to look at that. And then when it comes to our magnetic course, this is simply adjusting the true course for variation. Okay, and the difference between those is kind of like what would be essentially the wind correction angle. And in this case, it's only a degree. Right, so it's pretty small, and mainly because when we look at this, we're getting a tailwind of about 6 knots. Okay, so most of that 7 knots is right exactly on our tail. All right, let me go in. Let's kind of take a quick second, and we'll talk about the effects of wind and so on. So when we talk about winds, we are navigating. There's wind, variation, and deviation that we have to take into consideration. Deviation is a third one that I have not talked about yet. But I mean, we get it, right? It's pretty straightforward. If I'm flying in one direction and I have a 20 knot crosswind, right, and I just fly straight, not paying attention to the crosswind, in 1 hour of flight, that 20 knot crosswind, that 20 nautical miles per hour, is going to push me off course by 20 nautical miles. So wind is a pretty big influence on our flight planning. Okay, So when we take this into consideration, we're going to consider crosswind, and then this over here shows us the effect of a headwind versus a tailwind. Tailwinds are always good. We get there faster and save fuel. Headwinds are the bummer because now we have to deal with slower ground speeds and burning more fuel because we're spending more time in the sky. Okay, so again, taking a look at this, this is the drift angle, so we're going to have to correct for that. And the nice thing is that ForeFlight does that for us. Okay, so now you can see with this correction, we've corrected for the wind. We can hold our ground track and stay on our desired course to get to our destination, and we've compensated for the winds. Okay, so when we deal with that and we look at this magnetic heading, right, there's two things. One of them is winds have been considered for this. The other one that I'm going to show you right now is going to be the idea of variation. Variation is also addressed. So what is variation? Magnetic variation is the influence, or basically the differences in the magnetic fields on the Earth. This little chart right here kind of shows you what some of those are. And you can see that some of these are set up as red and some of those are blue. It just shows the difference between correcting east and correcting west. Okay, so for example, if we're over here on this side, we call it east variation. If we're over here on in the blue, we call it west variation. Okay, I've got another picture I'll show you that may drive that home a little bit more. So how do we get that number? How do we employ it? How do we use it, type of a thing? Well, we're going to need to look at our sectional chart. Okay, and so when we look at variation, in this case, it's 11 degrees and 15 minutes east correction. Okay, so this is the difference between simply looking at the magnetic fields on the Earth and what our true course is over the ground, right? So when we plot, we're planning our course over the ground. And again, we have to get all of this data back into the airplane and make it usable for us in the airplane. And so we have to consider variation, deviation, and wind correction angle. Okay. So far, okay, again, we've addressed wind. I think that's pretty straightforward. It's kind of obvious there's a wind influencing us. Variation is a little less straightforward, but it's based on, again, these differences in magnetic fields. The magnetic fields have an influence on the compass, and we have to correct for that in order to get the best outcome, if you will. Okay, that is to get to our destination. In this case, in Southern California, this is over near Mission Viejo, Laguna Hills. It's 11 degrees and 15 minutes east. Kind of round that off to simply 11 degrees, and then that's going to probably be, as we say, good enough. Okay, so when I come back over here, let's take a look at this again. So Santa Monica to my top of descent, 324 is my magnetic heading. Okay, and again, magnetic heading is going to be two things. It's going to be the wind correction angle, and it's also going to be the variation. Okay, so both of those are taken into account. Okay, the unique presentation where they talk about magnetic course, this is only looking at the wind correction angle. Okay, and this will change, based on the influence of the winds on your course. All right, so 324 is in this case what that amounts to be. Okay, and then Santa Monica at the top of descent, 324 to 323. Okay, the next column is going to be our speeds, our ground speeds, and true air speeds. True air speeds are based on temperatures aloft, okay, and true airspeed is simply the speed at which we're traveling through the air. It's a better number when it comes to how fast we're actually moving through the air, and then ultimately what we care about is how fast are we going over the ground. So if we're actually moving 120 knots through the air and we have a tailwind of 6 knots, my ground speed is 126 knots, right? So that tailwind is giving us that direct push, which in this case is pretty nice. Okay. Then the next one is distances. So the way ForeFlight does this in many nav logs, what is this leg, and then how much do we have remaining? Remaining becomes really important when we start worrying about, or if we get into a situation where we have to worry about fuel burn. Let's say we had unusually strong winds or something like that. That's when we really, really need to be paying attention to, can I get to my destination with the fuel I have in the tank is the big question. All right, so let's look at this. So the leg in this case, again, so Santa Monica to top of descent, this leg is only 4 nautical miles. Okay, and what's left, okay, when I get to my top of descent, we're going to be sitting out at about 34 nautical miles. I'm sorry, let me do that again. Yeah, that's right. So when I get to this point right here, my top of descent, we're going to be at 34 nautical miles. Okay, so from Santa Monica to my top of descent is going to be 4 nautical miles. I will have 34 remaining when I get to my top of descent. Let me do the next line just to make sure that it makes sense to you and I'm being clear. So when I get to my top of descent, I have 20 nautical miles to my final destination. Okay. Or I'm sorry, I'm 20 nautical miles into my flight, okay, from Santa Monica to top of descent. And then to my destination, what's left in this case, because this is the last leg, is 14 nautical miles. Okay. And then so Camarillo, when I'm here, right now it's 14 nautical miles and I have nothing left because now I'm at my destination. I hope that made sense. Okay. And then over here, this is speaking to fuel. We take off with 52 gallons. We burnt 1 gallon on the ground for taxi and run up. This is how much fuel we have at this position. At Santa Monica, we have 50 gallons. At top of descent, we have 48.4 gallons. At Camarillo, we have 47.3 gallons. And that's what we should have when we land. Maybe 46 gallons after taxi and shutdown type of a thing. Next column, this is pretty straightforward. This is how much fuel we used. And then this is our fuel flow, okay, estimating how much fuel we're doing. So in the climb, we're burning about 14 gallons an hour. Straight and level, about 10. Straight and level, about 10. And in the descent, we've pulled the power back and we're starting a descent and we're burning 7.3. Again, this goes back to our performance model that we selected earlier, which in this case is going to be this line right here. Okay, and based on minimum 500 feet per minute kind of changes on that. Okay. And so this now gets into times because time is important in terms of, when are we getting there? Are we getting delayed? Are we getting there faster? Those elements play into the significance of the flight. Again, the planning of this is really helping us mitigate running out of fuel, knowing how much fuel we have in the tanks. Okay. And again, when I started this, we started with a very conservative fuel management plan. So basically we're taking off with full fuel. But if you had to add a lot of weight, let's say we had 4 passengers and, even more baggage, the only way to keep the airplane within weight limits would be to not fuel the tank or not fill the tanks, if you will. Okay. All right. So going back to this, the amount of time is about a 27-minute flight after taxi. Okay, and then this leg will be about 7 minutes for the climb, 20 minutes remaining, 2 minutes for that leg, 18 minutes remaining, 10 minutes for this leg, and then 8 minutes remaining, and then 8 minutes to our destination, and then 0 time because there's nothing left after that. And then this would be estimated time en route, actual time en route. So it's expected that you would put some numbers below this. So how much time did it actually take you? Well, the planning was 7, but it actually took me 6 minutes. Okay. The planning was 9, but it took me 10 minutes, whatever the real numbers are. And it's important to track these because if we don't, An unexpected headwind could be a problem for not allowing us to get to our destination with sufficient fuel. Okay. ETA, estimated time of arrival, and then actual time of arrival at each of the waypoints. This is dependent on our departure time, and then going from there. Okay. So that is our nav log. You should be able to go through one of these and, tell me, okay, we're going direct from Santa Monica to here, top of descent to Camarillo. We're going direct. This is our elevation. This is our minimum sector altitude or safe altitude in the area. Okay. I'm not going to go into detail on that, but that has to do about terrain and those kinds of things. This next one, and this is this is where the theory starts to hit the application. We have a tailwind of 6 knots. We have a winds 132 at 7, temperature 17, and then a ISA, which is the temperature in relation to standard temperature of plus 11. So it's 11 degrees warmer at 4,500 feet than normal. Mag heading course, and again 279 in this case, and then 280. So it's only a 1 degree differential. Okay, and again, magnetic heading has to do with wind correction angle and variation. So we apply both of those to get this number. And then magnetic course, okay, all we're applying is variation to get that number. Okay, so in other words, the difference between these two, and we have a 1 degree wind correction angle on this. Okay, so 179 to 180 to 179. Okay, so we have to turn left 1 degree or hold a 1 degree left correction on that. Okay, ground speed 120. We're getting a push of 6 knots. That's showing up here. There's my 6 knots. Distance, this is my leg. Okay, so this is what this leg is going to be. And then this is what is remaining after this leg. Okay, how much fuel we have, fuel burned on this leg, how much fuel flow we're consuming. That's based on the performance. And then here are our times. Should be 10 minutes for this leg, 8 minutes to get to my final destination. Okay, 8 minutes for this leg. And then there's no time to my next leg or next waypoint because there is no waypoint. And then these are my times. Okay, so these are raw data. So 7 minutes to here, 9 more plus 19 plus 17 or 27. Sorry, these are estimated time en route. So 7, 9, 19, and 27. In other words, if I started a stopwatch, when I got to my top of climb, we should see 7 minutes on the stopwatch. When we got to Santa Monica, I should see 9 minutes on the stopwatch. Hopefully that makes sense. Okay, and then ETA, estimated time of arrival. These would be actual times that we would, employ. So I'd put in, okay, I'm taking off at 11:30. Okay, and the 11:30 time is our time of estimated time of arrival. So we're departing. How long is it going to take me to get to my next leg? If I depart at 11:30, I should be at my waypoint at 11:37. Okay, that's how that should work out. Okay. All right, so that is our navlog. Hopefully that was productive. I'll give you a couple of other highlights on what is the rest of this. So taking a look at this next area here, we've got an arrival ATIS. So this printout, when you print it out for your cross country, gives you a location to write any kind of weather information at the destination. Altitudes, okay, so this gives us some idea of what's going on at different altitudes, 2,000 to 8,000 feet. Here's your wind effect. So there's a headwind of 0 in that case at 2,000, tailwind of 5, tailwind of 4, tailwind of 3. So that would be the influence of wind at these different altitudes. This is the effect that would have on the timing of your flight. Okay, so 26 minutes to destination at 4,000 feet. If I spent the time going up to 6,000 feet, it would take me 29 minutes to get to my destination. Okay, so 4,500 is kind of sort of the sweet spot, okay, at 27 minutes. Okay, again, how much fuel I'm burning if I made these adjustments for those altitudes, and then time in terms of if I changed the power setting and made some adjustments, I would save fuel and I would take more time to get there. Okay, so what's more important? Do I need, instead of 5.3, I'll burn 5.2 is 0.1 gallons worth 1 minute, right? We're talking about small numbers, but when we start talking about multiple gallons, it does start to play into this when you're dealing with $8 a gallon for fuel type of a thing. This is nicely done. So we've got departure frequencies. Super nice to have that. Let me tell you, when you're looking for something, instead of using the chart, this plays in pretty nicely. And then our destination. And the other nice thing, we've got a simplified airport diagram, taxiways, and locations of FBOs and those kinds of things. So a pretty cool setup, pretty cool operation. The way they've got this set up. So any questions, let's get those questions answered if you have them. There's always lots to know, but hopefully this gives you a pretty good idea of variation and wind correction angle. The one I've left off is called deviation. ForeFlight will not address deviation inside of this because deviation is unique to an airplane. So when we talk about deviation, we talk about a deviation card, which is the error that the compass has based on where it's installed in the airplane. All right, what do I mean by that? Well, when a compass is installed, it is a magnetic device and it's influenced by magnetic fields. All right, sometimes steel and iron and those kinds of metals have magnetic fields around them. And another good example is if we turn a radio on or any kind of electronic device, you are going to create an electric field if electrons are moving through that device. So if we turn a navigation radio on or a communications radio, it's going to influence the compass. The deviation card, okay, is unique for each airplane and corrects for what is the difference in this airplane for that particular correction. Every airplane is a little bit different. In fact, if you change anything in the airplane, these numbers can change as well. Okay, so that becomes kind of maybe that's a good spot to conclude with what we're doing. Okay. All right. Have a nice day. Any questions? Certainly get your hand up and get either your hand up or send an email or send a text message or go into the chat and kind of talk through what's going on here. So hopefully this video helps to contextualize those three ideas: variation, deviation, and wind correction angle as it relates to ForeFlight, right? And you just have to be able to describe each of those similar to what I did inside of this video. Thanks, and have a great day.